Now, in this session, we are completing what we have started in chapter 14. As I mentioned in the email I have sent you, the midterm exam covers chapter 9, chapter 10, chapter 12, chapter 13, and chapter 14. Okay, chapter 14, as we have explained last week, is discussing sorting and searching. Okay, so far we have discussed two sorting algorithms, or actually 3 sorting algorithms. The first one is the selection sort. Okay. Here we go. Okay, this is our selection sort. Please make sure for each algorithm, for each sorting algorithm, you need to know a couple of important things. First thing, you need to understand the idea mainly. Okay, so for instance, for the selection sort, we agreed that 2 main things we are doing. First, search for the minimum value in the array, then swap it, then do the swap. Okay, so find the smallest and swap it with the first element, etc. Then find the next element in the remaining array and swap it. So as we explained before, if I have this array from 5, 9, 7, 11, 12, so I will start and say that I have 5 in my hand, and then I will search for the minimum value in the remaining array. Or actually, we will start with this by saying the minimum value is 5, so I will position it in the beginning. Okay. Then I will search for the next minimum value or the next smallest value. I find that the next smallest value is already in place, so no problem. Then we can go and find the next smallest value, etc. Once I find the next smallest value, I place it next to the value that I have put in my position and swap it. Okay? So 2 main methods. We have already explained this before. So 2 main methods in my selection sort: the searching for the minimum position and the swapping of the minimum position. Okay? Now also make sure, this is the main idea, make sure that you know how to write the minimum position, how to write the code for searching for the minimum position, and how to write the code for the swapping. Okay? And in case you might get in your programming questions in the exam that one line is missing, you might get a message, one of the things that you have learned, okay, for instance, the minimum position or the swap or whatever, okay, and then a line is missing, then you must be able to complete these lines of codes. And also make sure of the following, that you understand each step in the code. I don't want you to learn the code by heart. Most important, you know why you are writing this code. Okay? This is the first algorithm, selection sort. Then, okay, also we said you need to know the idea, you need to know the implementation of the main method of the sorting method, I mean. Okay? Second, you need to know the performance of this algorithm, or of this sorting algorithm, all right? So, okay, and the self-check questions, again, please, I don't want to repeat myself. You need to make sure that you are able to answer each self-check questions. First, understand it, and then if you want, I don't want to say learn it by heart here, but again, do whatever you want. Most important, you are able to understand, to answer all self-check questions in case you get any of them in the exam. Okay. Now, when I mean when I say the performance of each algorithm, I mean here the big O notation that we have discussed before. Here we go. Okay. As we said, the selection sort has an ON square efficiency. This means that you need to understand what the n square means. So we're talking here about the processing, or how much the algorithm is how much the sorting algorithm is growing. So for instance, as we said here, if I have O(n squared, this means that if I double the data set, means a 4-fold increase in processing time or number of visits. So please make sure that you know what is processing time. It's very equal to the number of visits, okay? When you're asked, is this algorithm fast or slow, this is very important to know. You need to know that it is n square, the big O notation, that's it. We have already explained everything here. Then we have also discussed the insertion sort. Again, you need to understand the main idea of the insertion sort. Okay? And the main idea means here that you need to know what's going on in the sort method. Okay? Again, we have explained before in the last virtual session, and we have traced the code as well. So please make sure that you understand what's going on here. Again, the performance of this insertion sort, you need to know it. It's already mentioned in your textbook and also in my notes in the code. Then the third sorting algorithm that we have discussed was the merge sort. We said that, by the way, the insertion sort is as efficient as the selection sort. So it is, again, O(n square, big O notation of n square. For the merge sort, it is faster than both the selection sort and the insertion sort. Again, you need to understand how you do it. Okay, the main idea. So again, you need to understand what's going on in the sort method. All right. And also the efficiency of this merge sorting. And as we mentioned before, it is n log n. So again, it is much faster than the other two algorithms. Also, you have to be able to make a merge sort manual, like the one mentioned here in this example, in the self-check questions. When it tells you, if you have an array of these numbers, can you sort them using a merge sort algorithm, or can you merge them using a selection sort or an insertion sort? So please make sure that you can do that manually. When we say manually, so don't write any code, just write it as in plain English. Do we agree on that? Do we agree on that? Okay. Then the final or the fourth algorithm, sorting algorithm, is called the quick sort, which we will discuss now. Okay. Now, the quick sorting algorithm is very similar to the merge sorting, where in the merge sorting we used to do what? We used to have an array, cut this array into two halves, all right, and then sort each half. But in order to be able to sort each half, then we kept cutting each half into two, and then until we finally reach one value, and then we started merging the remaining values. So again, we are depending here on splitting or dividing the half, dividing the array. So divide and conquer, the same concept as in merge sort. Okay, but the difference here, in the merge sort we said we're splitting the array into two halves, into two equal halves, or if the array was had odd number of elements, so it's almost a half. Okay. However, in the quick sort, we do still partition or divide the array, but based on a different criteria. It's not always the half. It can be, if I have an array, for instance, of 10 elements, I can have 2 as one partition, and 8 elements as another partition, or 3 and 7, etc. So there is a certain criteria. We will discuss it later. Okay. Once we get our partition in the array, we sort each partition. We sort each partition. So as you see here in this slide, the partitioning is actually not equal. So I have one big partition and one small. What is the partitioning criteria? I will explain it later on. Then we sort each partition. So we have now two main methods, partitioning and sorting. Okay? So here we go. Now if I want to sort, again, as we are used to, we're having like a top-bottom approach. So if I want now to define the sorting method, it will be public void sort. Okay. Now to sort an array or to sort a partition, it must have a start and an end. So we call that int from up till int 2. Okay. If the start is greater than or equal to 2, then return. This means that I'm outside of the array. Okay. So as long as the beginning is less than the end, no problem. Then, when I want to sort, I will first get the partition. So I will have a method that is called here partition. Partition which array? Partition the array that starts from position from and ends at position 2. Okay. Now, when I call this partition method, it returns a value. I'm storing here in P. This value is actually the position in the array at which I am partitioning this array. Again, when I call the partition method, I will give it the total number of elements of the array. So I will give it the start and the end of the array. Okay. Then it will give me an index or a position. This index is the position at which I will split my array. Once I get this split, so for instance here, I have this array, okay? In my sort method I call partition, so it has partitioned my array into this position. Now if I want to know what is this position, so 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, okay? And then here I have 5, 6, 7. So it will return actually a position of 5. Okay, this means that at position 5, I will split my arrays, and here it is split. So this is what's returned in my sort method. Now, once I have this partition, once I have this position, then I know I have now two parts of the array, as we have here. This part and this part. Now, what are we going to do? Same as the merging sorting algorithm. Each partition, I will again partition it, okay, and then into two other partitions, and then sort it. Here we go. So sort, I will call it again. This is a recursive call. So sort. Now sort from where? Starting from where we have started up till P, which is the position at which we have partitioned, and also sort the other partition, which is starting from P plus 1, ending with 2. Is everyone following? Is everyone following? For your question, Hafsa, I have said we are just partitioning it, but I haven't mentioned yet the criteria based on which we partition our array. I will explain it right away. Okay? So we don't choose actually; it's not randomly chosen. There is a certain rule. But so far, it's very similar to the merge algorithm. We keep partitioning our array, okay, up till we reach what? And when are we going to stop? Once we have actually one element. So once from is equal to 2. So no problem. If from equals to 2, this means I have only one element, so return. If from is greater than 2, then this means we're out of the array, so return also. Okay? That's it. Now, how do we implement the method that is called partitioning? Now we go to our code here. Here we go. So as you see here, this is my class. It's called QuickSorter. I have a constructor which initializes my array. The array is private int a. Okay. Now I have this is my sort method. Okay. Now a very important note here. This is also mentioned in the palindrome method in chapter 13. Now, I know that I must have a method that is called sort. All right. We all understand now the method that is called sort here. This one. It takes the beginning of the array, the end of the array, and keeps calling itself until we stop. So this is a recursive call. So make sure that you say here, this is a recursive method. And this is a recursive call. And also this is another recursive call for the other partition. Okay, now to make the code a bit easier, or to make the code look more professional, okay, we use something called helper method. What is the helper method? I'm just providing the user with a very easy method that to which the user doesn't need to pass any parameters, and from inside this method I will do everything. So when the user now wants to test the quick sorting, I will make the user call which method? Public void sort. Just sort and empty brackets. Now what will happen here? This is my duty, this as a programmer. So inside this sort method, I will call the other sort method, which takes the parameters, the beginning of the array up till the end of the array. So when the user now wants to sort an array, he just needs to call the sort. The user doesn't need to tell me sorted from this point up to this point. I know that. So the user can here call the sort method, the empty one, and inside this method, I call the other sort method. Now, an important question here. Someone would tell me, Tab, why do they have the same name? Of course, I can make them have different names, so no problem at all. Now, the second thing, the important question that might come to you in an exam, is this call a recursive call when I call this sort method here? Someone will tell me, yes, it is recursive because this is a sort and this is sort. I will say no, because the sort method here doesn't take any parameters, empty. While the sort method here takes what? I'm calling this one. So this one, if I stand on this one here, it will actually refer to this method, not to that one. This is the one that takes 2 parameters of type int. And here we go, 2 parameters of type int. What do we call that? Oh, method overloading. Don't forget that. We have already learned this in your in last term. Method overloading. Okay? So please make sure, if something like that comes to you, don't say that this is a recursive call. This is just calling the overload method. So we're calling here the overloaded method, which is the sort takes int and int. And what do we call this one? It's called helper method. Why is it helper? Because it's helping the user. It's making things much more easier. Okay, the same thing we did actually also in the palindrome code, in the palindrome method in chapter 13. Is everyone following? So we now understand the difference between this sort method and this sort method. Okay, perfect. Okay, now we can continue. And this is our recursive method that we have just explained. Now what's left here is the partitioning. How do we partition? What is the criteria based on which we partition our array? Here we go. Now I will go first to the PowerPoint and explain it from here. Now, imagine this is our array here. This is my start is called from, and my end is called to. Okay? Now, I need to make sure. First, I will set a value called pivot. I will set a value called pivot. The pivot will take the value in the position of from. So I have now a variable called pivot, or an element called pivot, and this pivot will take the value of the array in the position from. Now, I need to make sure that when partitioning my array, that I will, in this array, all elements or all values are put here on the left side next to the from, are all less than or equal to the pivot. Okay, less than or equal to the pivot, while all elements greater than the pivot value are put here in that site. So as if I'm saying, I will put here like from, and I will assume that have, for instance, this is I and this is j. So from point from up till position I, all elements here are less than or equal to pivot, while from position I to position 2, all elements here are greater than or equal to pivot. So I will show it to you here again. If I have such an array, okay, do you know, and this is an array that is partitioned. Have you noticed something here? Have you noticed something here? All values here are less than the values than here. So I need to make sure that in one partition I have all values that are less or equal to my pivot value, and in the right side I need to make sure that I have all values that are greater than or equal to my pivot value as well. Okay, now how do we do that? So far, is everyone following? Now, how can we do that? This is a very important question. I will go now to my code and define a method that is called partition. So private int partition, it starts from, it takes two parameters, int from and int to. So this is the range of the array that I am partitioning. Okay, and as I said, I will define a variable called pivot of type int, and this variable will take the value in from. So in this, which is the value at the beginning of the array. This is how we are starting. Now, what is I and j? In the beginning, here, in the beginning I don't have actually I or j in this array. So my I will be positioned here outside the array, before from. So this will be from -1, because from is actually starting from 0, with 0. And with for j, it's also outside the array at this side, so it is actually 2 plus 1. So in the beginning, in the very early step, I don't have I and I don't have j. And where are they positioned? They are positioned here for the I before the from, and the j is also outside the array next to the 2. Okay? And then, so here we go. Int I is from -1, and int j is equal to plus 1. Everyone following so far? Everyone following so far? Okay. Now what I want to do is, now focus on this point. What I need to do is, I will look now over my array. So far the array is not partitioned. I will look now over my array. Starting from which position? From the position that is called from here. And I will look at my array going here forwards. So using the index I. In order to move forward, so I need to say I++, because I is equal actually now to -1. So 0 minus 1 is -1. I'm standing here. So in order to loop over my array, I will say I++. If the value in the array at position I is less than or equal to the value in pivot, okay, then keep going to the array. So make sure that the value at the position of I is less than or equal to pivot. So I have no problem here. Okay? Now, when will I stop? I will stop once I find a value that is greater than my pivot value. So then stop. So as if I have stopped here. What about the j? Also at the same time, loop backward on the array. How do I do that? J was here 2 plus 1. So if I want to do backward, so I will have to decrement j each time, so j minus minus, and I will compare also if the value at a of j, at a of j is greater than or equal to the value in pivot, then keep it as it is, and go to the next element, or to the previous element in this case, until you find an element that is actually less than the value in pivot. So I'm looping that way I'm going here forward, and I'm going here backward. So everyone's following so far? Everyone's following? Okay. And this is what we are doing here. Here we go. So now I have the value. Well, now I have a variable called pivot again. This pivot takes the value of at the position of from. So in my case here, I'm starting from 0, so it will take the value in position 0. That's it. Now I have two indices, one that starts from the beginning of the array and one that starts from the end of the array. The one that starts from the end of the array is called I. The first, at the beginning, it has a position of from -1. It's outside the array. J is also outside of the array from the other side, so it's equal to 2 plus 1. Then, while I is less than J, what does this mean? While I is less than J, because if I is greater than J, this means what? I'm out of my partition, because I starts from the right, and J starts from the left. Okay? Sorry, I starts from the left, and J starts from the right. So now, as long as we are inside in this array, I++, this is the first thing, because I want to move forward now for I, and then make a very simple loop. While A of I is less than pivot, then I++. While A of I is less than the pivot, so make sure that all values are here what? Are less than the pivot values. While A of I is less than the pivot value, then increment I and keep going on. So the loop will, by the way, this is only one statement. However, this is how it looks like. If it's only one statement, so I don't need to, here we go. I can put it that way. That's it. But if it's only one statement, I know I don't need to put these bracelets. Okay? So I will keep looping up till the loop stops. And when will the loop stops? The loop will stop at the position of I, where A of I is actually greater than or equal to pivot. Do we all agree on that? Do we all agree on that? So that's why, if I go back to my PowerPoint, here I will keep going and going and going up till, let's go here to this point. I will keep going up till the values, all the values here are less than the pivot. Okay? What about the second one for J? Again, J minus minus. Why J minus minus? Because if I was here at this position, at 2 and J is here, in order to move backward, I need to decrement it, so J minus minus, okay? So we go back now, and while A of J is greater than pivot, then J minus minus. So the loop will stop at the position of J where A of J is what is less than or equal to the pivot. That's it. Then, once this loop stops, and this loop stops, then what are we going to do now? Now I have a position, I have a situation where I have here an I and I have a J. I have stopped here at an element which is greater than or equal to the value of pivot. And as I said before, all this area I needed to be less than the pivot. And here I have stopped at a position or in a situation where I have a value that is less than or equal to the pivot, and as we agreed before, all this area needs to be greater than the pivot. Okay, so what shall we do now? Huh? Any idea? Any idea? Exactly, Dua, swap. Perfect. Bravo عليك. So what shall we do here? It's a swap. We'll just swap. So we go back to our code now. And I will call my swap method. So if I is less than J, so make sure that you are within this, the right range, then swap I with J. What do I mean swap I with J? Are we swapping here indices, or we're swapping the values in these indices? Again, we are swapping the values in these indices as we did before with the insertion, with the selection sort. Okay? And finally, return J. Now, what is, if I less than J, then swap them. And once we are done here, So we are done now. Return J. What is J, girls? J is the position at which I will partition. J is the position at which I partition. I start at the position where I cannot continue anymore. Okay? Why? I have started at the position where A of J is now less than or equal to the pivot, so I cannot continue. So return J. Alright? Now, a brief about the swap here, very simple. The swap method takes two indices, two parameters of type int. It will take the value in A of I, so we'll store it in temp. Now A of J will equal to the value in A of I will take the value in A of J, and A of J will take the value in temp. That's it. So this is for the swap method. Now once the J is returned, remember what was this method? It's partitioning. Here I'm receiving my partition from 2. Now I got the position at which I need to partition my array. What shall I do now again? Again, call the method that is called sort. From, it starts from the value from the position from up till what? Up till P, which is the position of the partitioning. And so it will call the sort again and partition it again. And what is the second partition that needs to be what's the second partition that needs to be sorted again? It is P plus 1, so starting from P plus 1 up till 2. So again, this is a recursive call, and this is a second recursive call. What will happen here actually? It will keep, since I'm calling now sort from up till P, it will keep calling this method until I reach only one element, and that's it. And now, as we are used with recursive methods, it will position the minimum value in the final correct location, okay? And we'll continue. Then once this one is done, it will go to each of the other partitions that we have created. Is that clear, girls? Is that clear? Okay, I know that it could be a bit, it's very similar to the merge sort. The main idea again is to understand the main idea is to understand how the quick sort is working, okay? And the following notes are very important that I have written for you here. We already mentioned this is the recursive. Okay. Now, the pivot element. Now, a couple of notes about the pivot element that we are defining. The pivot element is not necessarily located in the first or second half of an array. For instance, in the merge sort, we usually have two halves, all right? However, in the pivot element, it depends on where the partition is. So it might be at the beginning, it might be at the end, it might be in the middle. It depends on where I am partitioning. So for instance here, when I said the partition P is, I have returned here P, which is the partitioning position. Now I will sort in the first one starting from up till P, and then here I will start from P plus 1 up till 2. So this means the P plus 1 will be now what will take this is the position where I will put my pivot element. So it's important to know that it is randomly located based on the partitioning rule. So the pivot element is in each iteration it is randomly located. This is first thing. Okay, also know the following, that all elements to the left are always less than the pivot, less than or equal to the pivot, while all elements to the right are always greater than or equal to the pivot value. Okay? Another important, do we agree on that so far? Are we agreeing on that, everyone? Everyone's following? All elements to the left should be always less than or equal to the pivot, while all elements to the right should be always greater than or equal to the pivot. Please don't forget these points. Okay? You might be asked about them. In whatever way. Okay? Also, what is the worst case scenario for a quick sort? Do you have any idea? Could you imagine if I have this power now back here? You see what we are doing every time? We are partitioning, and then each partition In this partition, we have all the elements that are less than the pivot element, and in this one we have all the elements that are greater than the pivot elements. Now, the question is, what is the worst case scenario for the quick sort? I will tell you right away. The worst case scenario is when the data is already sorted, but in descending order. This means what? That I will have the largest value in the very beginning, and already the area is and the whole array is sorted in descending order. So this means I will have something like that. When they have the same value, if they have the same value, I have no problem, Hafsa. But if it is already sorted, you know, when I said it is already sorted in descending order, this means what? This means that in order to, I will have to loop over each element, or over each, I will have to make many visits to this array until I get all small elements to the left and all large elements to the right. Are we following? So, as if I'm saying here in this PowerPoint, this is how it is sorted. Imagine that this array is sorted already in, I don't know how we can do it here. Okay. Imagine that this array is already sorted that way. 7, 6, okay, then 5, then 3, then 3, sorry, if we have 4 first, 4, then 3, then 3, then 2, then 1. You see what's going on here? This array is already sorted in the quick. So if I run my quick sort algorithm, this means that all these elements will have to go to the other side and vice versa. So the worst case scenario is when the array is already sorted, but in which order? In descending order. Or if the values are very randomly initialized. Do you remember when we mentioned the arrays class? And we had actually in the session before, when we have created a class called ArrayUtil, and we have created a method that initializes the array randomly by using the random class. Do you remember that? So each time I have a random number of values in my array. So I can have the largest element in the beginning, the smallest element in the middle, etc. So they are so complicated. So again, this could be also a bad scenario for the quicksort algorithm. But the worst case is when it is sorted in descending order. Is it clear for everyone? Is it clear for everyone? Okay. Now I'll go to my notes as well here in the code. What is the efficiency of the quicksort? The quicksort, since it is called quicksort girl, so it is actually a very quick one. So the efficiency is O(n) log n. Okay. So it runs faster than the merge sort in most cases. Someone would tell me, but again, we said the merge sort is also O(n) log n. But bear in mind that sometimes it is even faster than the merge sort. In case I have the worst case scenario where the array is already sorted in descending order, I might have a performance of O of n square. Okay? That's it. Also, if you have a very short array, it's a common practice not to use the quicksort algorithm, but to use the insertion sort algorithm, because if the array is short, we will have a very small number of operations. So these are the main notes about this quicksort algorithm. Is it clear for everyone? Okay, so make sure that you read the comments in every file I'm uploading. Now, we go now can now continue by taking the linear search. Now we have finished all types of algorithms, or of sorting algorithms. Now we are starting with the searching. Now what is searching? I have two types of search that you will be learning here. Something is called linear search and the other is called binary search. The linear search is extremely easy actually. If I give you an array, okay, the simplest thing, if I give you an array and I want to search for a certain value. So what I will do, I will loop over this array and check if my value is equal to the value at position of I, then return the index of this position. If not, then return just -1. So this means I haven't found it. Very easy. So this means that in order to make my search, I will examine all values in the array until it finds a match or reaches the end. Okay? So number of visits for a linear search of array of n. Okay. Now bear in mind, if you are asked about this question, if I say number of visits for a linear search, the maximum number of maximum number of visits will be what? Will be n, because I have here n elements. So I will be visiting each element. So the maximum visit is n. If I want to take the average, if I'm asked about the average number of visits, so the average search visits is n over 2 elements. I'm just taking the average. Okay, is that clear? So the maximum will be always n. If the average, then I will divide it by 2, so it will be number of visits will be n over 2 elements. All right? Then a linear search also locates a value in an array in O n steps. So the efficiency of the linear search is what? Is O of n. So if I now have, for instance, 100 elements, so the efficiency will be what? I will be visit 100 times. If my data set is doubled, then the number of visits will be also doubled. That's it. It will not be multiplied. It will not be squared. It will be if the data set is doubled, then the number of visits is also doubled. That's it. Very simple. Now, how does it look like? Here we go. Please make sure that you know the implementation of the linear search and the binary search. This is very important again. The same thing, we have a class, we initialize the array, we initialize the constructor, etc. until we reach the main method, the main idea here, which is the search method. Very simple. It takes it's called search. It returns an output of type int, which is the position. So if the position of where I have found my value. If the value is not found, it will return just -1. And here it takes the value that I'm searching for. So as I just explained, I will loop over my array. So starting with I equals 0, I ++, and I will stop until we reach the end of the array, a.length. If the value at position of I, of array A, is equal, don't forget the double equal sign, equal to the value that I'm searching for, then return I. What is I? The position at which I have found my value. So if the loop ends and I haven't found and I haven't returned anything, so this condition has been always false, then return -1. That's it. Then return -1. Is it clear? I think that's very easy. Is it clear, girls? Everyone? Or someone is missing something here? So now if you are asked in your exam to implement the linear search method, would be that a problem for you? Would be that a problem for you? I'm not saying that you will have this question, but I'm saying it's a very easy implementation. So make sure that you know it very well, okay? The same applies on the binary search, same applies on the recursive methods that we have mentioned before, okay? Yes, it is. All right. Now we go to, now this is how we implement the linear search demo. Very, very easy. I'm not going through that. Asking the user to enter inputs to scanner, equals new scanner, etc. So all this stuff, we don't need to go through it. It's very easy for you. Just read it. Make sure that if you run the program, you know how it's running. Again, the code will be uploaded for you. Okay, now this is a self-check question. Again, this is your responsibility. But you see here, it's a very tricky question. Suppose you need to look through 1 million records to find a telephone number. How many records do you expect to search before finding the number? If you answer on average, then you will just split it by half, so 500,000 comparisons. Okay? If you're asked about the maximum, so how many records, it will be 1 million records. So make sure that you concentrate or you focus. Okay, this is another of the self-check questions. Please revise it on your own. Now, what is the binary search? The binary search, it locates the value in a sorted array. Now, this is the first thing. Binary search, على فكرة, احنا we are doing it every day. I will tell you a nice example. Imagine you are having your book. You know that the pages in your book are sorted. Of course, they are sorted. So let's say that you have a page of 100, you have a book of 100 pages. So from page 1 up till page 400. All right? And then you want to open your book on page 90. What are you doing? What's the first thing we all do? We hold our book, split it, open it in the middle, right? Just split it into 2 halves, whatever the halves. I'm just opening it in the middle. Then I find myself, I'm, for instance, on page 200. What are we going to do again? Now, it's a book of 400 pages. The first thing that we do, I don't go page by page, of course. I just open it from the middle. I find myself on page 200. What are we going to do? In order to reach page 90, are we going to go to page by page, starting from 200 backwards? Yes, you will go back, Moj, exactly. But how will you go back? Page by page, or you will do another split? I will do actually another split. If I'm on page 200, then I will just split this first half again into 2 halves. Okay? And then I find myself on page 100, for instance, or 105, or 110. Okay, now I'm where? I'm very near to the 90, right? So I will take this first half again, which is which I've stopped, which is at page, for instance, 110. I will split it again until I find my page 90. All right? So this is what you all do, and this is exactly what's going on in the binary search. Now, the first condition, and I have colored it in red, in order to be able to make a binary search on any list or on any array, it has to be sorted, or else it doesn't make any sense. So imagine if my book hasn't been sorted, if my pages in my book are not sorted, so I cannot do this binary search anymore. So it has to be sorted. So if you are asked about that, or if you are given in any example, then make sure that you are doing the binary search on a sorted array. If the array is not sorted, then you cannot do any binary search. Everyone's following? Do we agree on that? Okay? Perfect. Now, what is the code for it? Very simple. I will just write what I have just explained. Here we go. Again, I'm having a class called binary searcher. Okay. I have here the variable called A. Again, I'm declaring an array of type int. Then I'm having my constructor, public binary searcher. It takes the array as parameter to initialize my array A. So it takes a parameter called an array of type int. The values in this array will be passed to the array A that is initialized in my class, or that is declared in my class. Then, not initialized, it is declared, okay? Then the main idea goes here. Again, this is what I'm caring about. Please make sure that you are aware of the implementation. You might be asked about how to implement the binary search. You might be given a couple of lines and you continue. Okay, so please make sure you know the code. Now, here we go. And of course, understand that you cannot learn the code by heart. One question before we continue. Afnan, have you been able to read or to revise the first sessions, the first revision sessions that we have done for that I have done for you? because you had a problem in a couple of things. Yes, and is it any better? Can you follow with us? You're following with us, Afnan? Okay. All right. If you have any questions, always keep in contact with me. Okay, please. Right. Now we can continue. Now the search method here, public in search. Again, this search method returns the position where I will find my value. This is first thing, or it will return -1 if the value is not found. Now, what will the search method take? It will take the value I'm searching for, so int v. So no problem. Okay. Now, in this method, I have two variables. The first variable is called int low equal to 0. What is low here? Low is the point from which I'm starting my array. This is of course in the very beginning, and int high is equal a.length -1. So if I'm searching in my book again, the low will be here, it will be page 1, and the high will be the last page in my book, page 400. In the case of array, the low will be 0, position 0, and the last element in my array, which is a.length -1. So this is the range I will be searching in. Okay? Then I will have a loop, which is while low less than or equal to high. This means what? As long as I have elements I'm searching in. We said that the low is the beginning, the high is the end. So for instance, if low is equal to high, this means that I'm having what? How many elements in the array? If low equals to high, how many elements? Exactly, Dara. It's only one element. If high, what if high, or if low is greater than high? For instance, if low now is -1 or high is -1, so this means I'm outside the range. Okay? So please make sure that while we are always low less than or equal to high, we do our search. Okay? Now how do we do our search? Here we go. You remember what I said in the beginning? I'm splitting my book into 2 halves, or I'm splitting my array into 2 halves. So how do I get my 2 halves again? Here we go. Low plus high over 2. Low plus high over 2. What is that? Now imagine this is again written. I have written the red colored words for you. This is not in your PowerPoint. So assume the following array. If A is equal to 5, 10, 15, 20, 40, 60. First, notice it is a sorted array, so don't forget that. If I give you something like that is not sorted, just make sure, tell me, oh, this is not sorted. We cannot do anything here, okay? So 5, 10, 15, 20, 40, and 60. So the low will be here what? 0. The high is equal to a.length -1. What is the position of the last element, which is the position of the last element here? So this is position of what? 5. 0, 1, 2, 3, 4, 5. So how do we get the middle? Low plus high over 2. Low plus high over 2. So 0 plus 5 is 5 over 2, which is equal to 2.5. We'll take only the integer value. So at position 2 is my middle. So 0, 1, 2, position 2 is my middle. I will color it here with, for instance, black. Everyone, okay? So my middle is at position 2. Everyone's following? Everyone's following? Okay. Then, once I have my middle, then I will calculate something called, I will now compare my value actually. My value is, let's assume I'm searching for the value of 15. So I know that my mid here is position 2, where I have the value of 15. So how can I do that? I will just make a comparison in terms of what? In terms of a subtraction equation. So I will say A of mid, which is the 15, minus the value of V, which is again 15, if 15 minus 15, this means what? The difference is what? Is 0. So this means the value is found, right? So if the difference is 0, because as I told you, if I have a book of 400 pages, okay, if I have a book of 400 pages and I'm splitting into 2 halves and I'm searching for page 90. When I split my book into 2 halves, I find myself on page, for instance, 200. What will I do? I will say, is page 90 equal to 200? I will say no. Is it less? Yes, then I will go to the lowest half. Is it greater? Then no. If it was greater, I will go to the bigger half, okay? So I'll make that in a format of a subtraction. So I will say, I will aim A of mid, the value at the middle, minus the value I'm searching for. Okay? If the difference is 0, then this means I have found my value. So 15 is equal to 15. 15 minus 15 is equal to 0. So no problem. So if the difference is equal to 0, then return mid. Return the position of mid. Do we all agree? Do we all agree on that? Okay, perfect. Now, what about if the difference less than 0? Assume I'm searching for the value of 40. Okay? Now, A of mid, which is 15, I know that the value at the mid position is 15. So 15 minus 40 is what? It will give me what, girls? It will give me a negative value. This means, is the 40, this means I have to go to which half? To the half before the 15 or to the half after the 15 if the value is negative? So which part I need to search now? After 15 or before 15? After 15, بالضبط. ليه? Because the negative value, exactly. I'm searching for 40, okay? When I made the difference, A of mid minus 3, it gave me a negative value, so this means this is a larger value. So I need to start searching from after 15. So now, what will be shifted? The low or high? I said the low is the beginning. So now I will search starting from low equal to mid plus 1. So now my new position is starting not at 15, not at the mid, but at the position after, which is the 20. In other words, it is mid plus 1. Okay? Type. What if the difference is positive? When will be the difference positive? If, for instance, I'm searching for something like 5. 15 minus 5 is 10, so this means I am in the lower range. So where shall I search? I shall search from the beginning up till where? Up till the position before the mid. So now the high is shifted. So high is equal mid minus 1. Okay? Is it clear, everyone? Is it clear, everyone? Okay, perfect. So now I will keep looping, okay, until I return what? Until I return the value. By the way, when do we find the value? When do you find the value? Until I find the difference is 0. Okay? So we'll keep splitting and splitting and splitting until the difference is 0, and then we will return, in this case, the position, and the position is stored in the variable called mid. That's it. Now, if the loop ends, and this one, if the loop ends here, okay, and I find myself, I haven't gone into any of these returns, so nothing. So difference was never 0, the difference was never less than 0, etc., or positive. And I have, in other words, I haven't returned any value. So in that case, return what? Return minus 1. Why? Because the loop. When will the loop stop, girls? The loop will stop once the low is greater than high. Do you know what this means? The low is greater than high. This means that I'm outside of my array range. So this means I'm outside of the array range, and I haven't found anything, so return minus 1. I will give you an example here. Assume I'm searching now for the value of 70. For the value of 70, okay? So now I will keep splitting my array into halves. So the first half was 15. So my mid was here. Then 15 minus 70 is negative, so I need to search in the greater half. So I will start now from 20. So the low is now what? The low is shifted. So the low is now mid plus 1. So the low starts from 1. Still searching for 70. I'm splitting that now from 20 up to 60. So I will be positioned at which position? At the mid is 40. I will compare 70 with 40. 40 minus 70 is again negative, so I need to do another split in this part. So the low is shifted now to where? To low, to mid plus 1, so now the low is here. And what is the high? The high as well is at that position, so the low is equal to high. So far the loop is okay because I'm looping up till where? Until low is less than or equal to high. Now I'm comparing 70 with 60. Get my middle. Now the middle is what? Low plus high over 2. The low is now position 5. The high is position 5. 5 plus 5 is 10 over 2. So again it's 5. So now the low is equal to the high is equal to the mid. Everyone's following so far? Everyone's following so far? Okay, the low is equal to the high is equal to the mid at this point. So now I will compare. Is my value equal to the value at the mid? So is my 70 equal to 60? No, because 60, which is the value at mid, minus 70 is negative. So what shall I do now? I will shift the low. I will shift the low again, so mid plus 1. So mid plus 1 means what? The low now will be at position 6. Do I have a position 6 here? No. So if I now go to the second iteration, it will find that the low is now what? Greater than the high. The high is 5 and the low is 6. So please stop. This means I am out of my array and I haven't found yet my value. Same wise if I'm going for the value of 4. If I'm searching for the value of 4, you will reach position 5, okay? And at that position you will reach position 0, where you have a value of 5. 5 minus 4 is positive, so I need to go to where? To high equals mid minus 1. 0 minus 1 is minus 1, so I'm outside of my range, so the loop will stop and I will return again minus 1. Is that clear, everyone? Is that clear, everyone? So please make sure that you understand that when you might be asked about something like that. Why do we have low, less than or equal to high? Very important for you, okay? So now the binary search is also done. Only one thing, again the performance or the efficiency of my binary search algorithm. How many visits do we have for an array of size n? Okay, we know that we visit one element, which is the middle element, then search either the left or the right subarray. Do we agree on that? So if I have now an array of n size, so I have t of n over 2, I'm searching the half of the array plus 1. So I'm visit one element in the middle, then search either the left or the half. We're not searching both left and half as we did in merging, not searching, I mean sorting. But here I'm only searching either one, either this half or this half. So it's Tn over 2 plus 1. Okay? If you continue with this equation and substitution, etc., just read it and make sure that you understand it. We finally reach this efficiency that in order to have a binary search for n elements, we have a log n algorithm. Okay? So in order to search for n element and a value, in order to have a binary search for an array size of n elements, okay, you will have to visit this array by log n, so it's very fast. Okay? In the case of linear search, which is also called sequential search, you have to search it how many times? O n times. Well, here it's log n times. All right? That's it. Now, any questions regarding the binary search? Is it clear, everyone? Okay, perfect. Now, I need you to give me 2 minutes, please. I will stop sharing because my computer is out of charge, so I'll get the charger and come back to you. All right? Just a second, please. Okay, we're back again. Now, here we go. Now, we have discussed searching and sorting algorithms so far that we have created ourselves. Now, the question is, can we have, do we have built-in searching and sorting algorithms in the Java library? Yes, we have. Where are these? The first thing here we know that we have a class called arrays in the Java library system. Okay, so the arrays class contains a method called, again, binary search. This method is static. So in order to call my method, I just say arrays.binary search and I will give it my array. Now it's important to know what this method returns. If the value is found, it will return the index of the element. So this means the element is found at this position. If the value is not found, it will return something like that. -k -1. Here I'm coloring it with red. Okay? Well, k is the position before which the element should be inserted. Now, focus on that part. For instance, if I have an array of int a equals 1, it has the following values, 1, 4, and 9. If I'm searching for the value of 1, so it will return the position where I have found the value, which is 0. Now what if I'm searching for the value of 7? 7 is where? 7 is not found. In our case, we used to do what? Return just -1, which means value is not found. But here it gives you an additional option. It's not only the -1, which is that one, okay, but also the position at which this value should have been inserted in your array. So it will return here -3. -3 means what? -k -1. The negative value means what? Means the value is not found, which is the -1. So remove the -1, you will have a remaining of -2, because -3 plus 1 is -2. -2 means what? This is the position at which my value, which is the 7, should be inserted before. So here, 0. I have the value at the position of 0. I have 1. At the position of 1, I have 4. Okay, it's telling me at the position of 2, I have 9. So it's telling me now the value of 7 that you are searching for is not found, and also it should be inserted before position 2, which is before the 9. What is the main use of that? That for you, in order to, it gives you an option that you can modify your array again. You know where you put it, and then you go and search for your value. And why it tells you where it should be put, because we agreed what? We agreed on the fact that binary search has to be performed on sorted arrays. So it tells you the exact position where to put it, and then you can continue with your binary search. I will give you here an example. Here we go. Can you see my editor? Can you see my editor? Okay. Here, I have created a class called built-in search and also sort methods. Actually, they are built in. Now, in order to use the class that is called arrays, I have to import it. So import java.util.arrays. Okay. Now let's assume I have the following array: int a equals 10, 15, 17, and 20. All right. Now, I said that the binary search method is static, so I can call it directly from the arrays class. I don't have to create an object of arrays and then call it. So arrays dot binary search. Here we go. If I click on it, it will give me how it looks like. Again, it is static, public static int. It returns an int, which is what? Which is the index of the value at which I have found my value, or the other index which we are explaining right now. It's called binary search. It takes two parameters: the array and the key or the value I'm searching for. Okay. So here we go. Int pos equals arrays.binary search. I'm passing the array a, and I'm searching now for the value of, for instance, 10, or let's say 15. So this value is found. If I click my runtime, here we go. Please ignore these two lines here. The value is found at 1. So value found at plus position. Here we go again. So the value of 15, which I'm searching for, is found at position 1, 0, and 1. No problem. Now what if so here, if position is greater than or equal to 0, then do this following: else system .out.println value not found. Okay. Or returned is, that's it. Okay. Now what if I'm searching for the value of 30? Okay, so 30 is where? It's not here. But if I wanted to insert the 30, where should I put it? Where should I put it? I shall put it where? After 20, right? So let's see how it looks like now. If I run my program, value not found, return is -5. Now what is the return of -5? Now let me give you first a simpler example and then tell you the 30. What if I'm searching for the value of 11, for instance? Here we go. Now I will keep the console open. Now the value is not found and the return is -2. What does -2 means? Again, I said if the value is found, it returns its position. If the value is not found, it returns what? A negative value of minus insertion point, the point at which I shall insert before, and it will add also a -1. Okay? So it gives me here, when I run my program, -2. This means, first, it is negative, so the value is not found. Now remove the -1 that defines that the value is not found. So -2 plus 1, in order to remove the -1, so I need to make the opposite operation. So -2 plus 1, this means that I have a -1 here. Or actually remove also the minus, so I have here position 1. So this means that the value of 11 should be inserted before position 1. Here we go. 10 is 0, 15 is 1, so 11 should be inserted where? Before position 1. Is that okay? Is this clear for everyone? Is this clear for everyone? Okay, perfect. Now this is for the binary search. Also, going back to my PowerPoint, a very useful question here in the self-check. Someone would tell me, why does the array.binary search return? Why is it that complicated? So why does it return -k -1 and not -k to indicate that the value is not present and should be inserted right away before position k? Wouldn't that been easier? Wouldn't that been easier? It makes more sense. However, if I do that, if it returns only -k, you see what will happen? You would not know whether a value is present when the method returns 0. Assume that the value I'm searching for is already at position 0. So the method will return 0. 0 here means I have found the value, or okay, at position 0, and sometimes 0 will mean here there's nothing called -0. So the 0 can have here now two interpretations. Either the value is found at 0 or the value is not found, but both will have the value of 0 because we don't have something called -0. That's why we do what? We do this -1. Okay, is that clear, everyone? Is that clear, everyone? Okay. Now I can continue. Okay, sorting read data. Another, now we're done with the searching. If back to the sorting, do we have a built-in sorting method? Yes, we do. In the arrays class, again, we have the method that is called sort. It implements which algorithm? It implements the quick sort algorithm. So please make sure that you remember that. The built-in method sort in the class arrays uses the quick sort algorithm. How we implement it that way? Very easy. Okay, if I have an array that is called B, it has the following values, 5, 15, 20, and 70. Okay, again, don't forget that if I'm calling the binary search of the arrays class, again, this is a binary search, so I should be working on a sorted array. Don't forget that, please. Okay, now back to my sorting. I have also sort method in the arrays class, so let's assume I have an array of B, 5, 15, 20, 17. So system.out.println, before the sorting, I will print my array. Do you remember I have a very nice method called toString in the arrays class? So arrays.toString, I will pass my array B. So, okay. Then I will call the method sort.b, so arrays.sort B, all right? It will sort my array, and then I will print it now after the sorting. So arrays again .toString B. Here we go. If I run it, before sorting, this is how it looks like. After the sorting, this is how it looks like. Very easy. Just remember how we call it. We call it from the arrays class. Remember that this is a static method, so we call it right away, arrays.sort. We pass to it any array, okay, and it implements the quick sort algorithm. That's it. Okay? Finally, now, a very nice thing that the arrays.sort also, I'll need to show you something nice. When I say arrays.sort here, See what's going on? I can sort anything. I can sort an array of bytes, characters, doubles, float, whatever. I can even sort objects. Oh, this is very weird. How can we sort objects? How can we sort objects? Now, this is how it looks like. Do you remember the coin class that we had? Do you remember the coin class that we had? The coin class, can we sort them? Yes, we can. Imagine that I have several coins. Now, in just real life, I have several coins. Each coin has a certain value. And if I want to sort them, I will sort, for instance, I will say that the nickel is less than comes before the quarter or the dime, and the dime comes before the quarter, because if I'm sorting them in an ascending way. Okay? Now, how can I do that? Here we go. So the sort method in the arrays class is very useful, but I can only use it given the following condition. Here we go. The arrays.sort also sorts objects of classes, okay? Given what? Given that they implement the comparable interface. Given that they implement the comparable interface. You know what is comparable? This means that this object can be compared with another object. If I have two things that can be compared, then this means I can sort them. Now, what is the interface? Back again to the first topic in chapter 9. Here we go. The interface just gives me the method signature, but doesn't give me the implementation. So this is how it looks like in the Java library. Public interface comparable. Okay. Then it has a method that is called compare_to. It takes an object, okay, and returns an int. It takes an object and returns an int. That's it. Now, the int means the return type means if the return type is negative, if it has a negative number, then this means a negative number if A should come before B. So if A should be sorted or should come before B. 0 if A and B are the same, okay, and a positive number otherwise if A should come after B. Now I will explain that in just a second. Now, the first important thing is what? It can sort objects, okay, given that they implement the comparable interface. Now, do we have already classes that implement the comparable interface? Yes. In the Java library system, yes, we have the string class and we have the date class. So both implement the comparable interface. Now, how can we make something like coin to be comparable? Okay, here we go. Maybe we can implement it right away with you here. I will take my coin class from, where was it? Week 1. Coin, copy. And I will copy it now in my project here of week 5. All right. Paste. Okay. I will take the measurable interface as well from here, copy. The coin class implements the measurable interface from week 1, so I need to put it also in the same folder, so I'm pasting it again here. That's it. Okay? Now, remember what we said? In order to be able to compare objects, it has to implement the comparable interface. And we know that a class can implement one or more interfaces. Please make sure that you know that point. A class can implement one or more interfaces. How do we do that? Just by adding a comma. So it will also implement a comparable. That's it. Okay? Okay, I need to, of course, Okay. Now the comparable is already seen, but what shall we do now? Since it implements the comparable interface, I need to provide implementation for what? For this method. What is the method called here? Int compare two objects. So I will just copy it as it is, add it to my coin class here at the very end. Okay, I will provide the implementation here. Okay, of course I will get an error. Why? First error, because this one needs to be defined as public. Second, I need to return something here. Okay, now how do we compare the coins together? How do we compare them? Here we go. I will copy this part as well. Now you see what we're doing? Here we go. Now let's experience step by step. First, if I remove the public here, girls, I will have an error. Why? Because, again, this is a very important thing for your exam, or one of the important common mistakes. We know that by default all methods that are defined in interfaces are public. So when you implement now the method that is in your interface in another class, okay, then you cannot give it, you must give it a public. You cannot give it a weaker access. The default modifier in any class for any method is protected. So this means package access. I don't need that. I need a higher one. I need something exactly like the signature of the method of the interface method. So it has to be public. You see? It's telling it cannot reduce the visibility of the inherited method from comparable. So I have to give it a higher access, which is public. So far everyone's following? So far everyone's following? Okay. Then the second thing. The compare to takes an object. So it takes a variable of type object. And now I need to compare a coin with another coin. An object, we know that any subclass, we know that already the object class is the superclass for the Java class hierarchy. It's the most general class in the Java hierarchy, the Java class hierarchy. And I can easily convert any subclass to a superclass. So I can easily convert a coin to an object. But can I convert it the opposite way? Can I convert a superclass to a subclass? No, I cannot do that. So can I convert an object to a coin? No. I can only do that with casting. I can only do that with explicit casting. So coin, I define a variable called coin other, equals the other object that is taken from the method here is of type object. I need to make it by force as a coin. So I do here the casting. Okay? We all know that. We have done it before. So coin other coin equals coin other object. Now, what do I need to do? I need to compare the values. I need to compare. Why? Because this is the only thing that I can compare in order to order the coin, the value, not the name. So if the value of what? If the value of the which is the 0.25 or 0.1 or whatever, less than the other dot value, the value of the object that is called here other, which is of type coin, then if this is less than that, then this is -1. This means what, girls? Return -1 means what? Means that the other, okay, has to come before that one. We go back to our PowerPoint. A negative, if A compared to B, if a negative number, if A should come before B. If A should come before B. So now we are right. So a negative value. So here the value of this coin should come before the value of the other coin. So no problem. If they are both the same, if they are equal, then return 0, else return 1. Is it clear so far? Is it clear so far? Okay, now what do we need to do? I will go now to my test here, which is called the built-in search methods. Okay, and now can I say something like that? Arrays dot sort and now objects? Yes, of course. So what I will do, I will create a couple of objects of type coin, and here we go. I will again take it from my PowerPoint here. I will create an array of type coin, okay, called x equals new coin. Same as we say int x equals new int. Now this array is not storing int values, it's storing what? It's storing coin values. Okay? Now what is the length of this array? I will just give it maybe 3 coins. That's it. And then I will say now coin C1 equals new coin. Okay? I will give it the name, whatever, anything. Maybe, okay, no problem, quarter. And then the value is 0.25. Remember? That's it. I think the value was in the beginning. Takes first the value. Okay? And then quarter. Here we go. Then I will have here a third one, so C2 and C3. This one is 0.1, and here we go, dime. This one is nickel, and it's 0.05. Okay. Now I need to add these coins or these coin objects into my array. So x equals simply C1, comma, C2, comma, C3. That's it. Okay. Or we can also do it this way. Just a second. X dot. Okay, it has to be, it's not accepting it as, no problem, x0 equals C1, x of 1 equals to C2, of course it can be easier using some collections, but I'm just making it simple for you. X of 2 is equal to C3. Okay? So far what have we done? We have created an array. Okay? This array called X, it contains a couple of objects of type coin. How did we do that? First we have to declare an array of type coin. This is the size of the array. Then we have created our objects, and then we have assigned each object to the relevant position. Now, can we sort them? Yes. If I now say arrays dot sort X, okay, first I need to print them. Arrays system dot out the print line. Before sorting arrays dot to string, the array is called X, and then same after sorting array dot to string again X, and now we can run. Before we run, again remember the problem was where in order to sort anything or any in order for the sort method to sort objects of a class, this class has to implement the comparable interface. This is the main issue here. So what we did, we got to the coin class. We have implemented the comparable interface. The comparable interface has a method called compare to. We have defined which things to compare, and then to return the values. Finally, we went to the quick sorter here. Sorry, to the method, to the class where we have the main method. We have now created an array of type that stores coin objects. Can we now sort this array of type object of type coins? Yes, because it implements already the comparable interface. Now we can run it. You see? Okay, we don't have the toString class here. I will. Before sorting, this is how it looked like, and this is the after sorting. You know where the problem here is? I haven't provided implementation for the toString method, so it's just giving my the hash code and the class name. So if I go now to the coin method, you know, because we said that the toString method has its default implementation. Default implementation is the class name plus the hash code. However, if it is defined, then it will provide me with what I need. So I take it from here. A quick question: do you know what is the toString method? Where do we inherit it from? Where do we inherit it from? Where do we inherit the toString method? Do you remember? Okay, the toString method, again, girls, don't forget, the toString method is inherited from the class object. So all classes in Java already inherit from either directly or indirectly from the object class, which is the root class. In the object class, we have a method called toString. The toString, if we call it, it gives me a string representation of my class. How does it look like? The class name plus its location in the memory, which is the class name plus hash code. If I want to have different string representation, when my toString method is called, again, the toString method is inherited from the object class. So in that case, I will override it. So override the toString method inherited from the object class. And here we go. Public string to string, now return the following. Coin plus the name of the coin plus 2 dots and plus the value of the coin. That's it. Okay? Is it clear, everyone, what we're doing here? Is it clear? Hello? I think something is missing. Hello? Have you been able to hear me? I think something was missing. Again, where did we stop? Okay. I see. Okay. Is everyone following what I have just said? The toString method. Is it clear? Okay. Now, does everyone understand why in the beginning it has printed the hash code? Does everyone understand why in the beginning it has printed the hash code, or someone is not following? Does everyone understand it? Okay. So now we can continue. Here we go. In the quick sort, in my class again, I will print it here. I will run my program. You see what happened now? Before the sorting, I had coin quarter 0.25, then the dime 0.1, then the nickel. Now after the sorting, the nickel is first, 0.05, then the larger one, which is 0.1, and then the quarter, which is 0.25. Okay, is it clear, everyone? Is it clear, everyone? So the main important thing here is that in order to be able to use the sort method that is in the arrays class of the Java library, in order to use it to sort objects of classes, we need to make sure first that this class implements the comparable interface. Second, if you want to sort a couple of objects from the Java of a class from the Java library system, then you have, for instance, the string class, the date class. These are classes that are already in the Java library system, and they implement the comparable interface. Okay. One final note here. It tells you if the objects are stored. Now, in my case, I stored the objects in an array. If the objects are stored in an array list, which is again another class in the Java library system, so in that case, you will not use arrays.sort, but you will use collections.sort. Okay, so the array, now you will have an array list to which you will add your coins, and then you will call the collections.sort. This is not an array anymore, this is a list. So we'll call collection.sort and you will give us the coins. For the collection.sort, it's using the merge sort. So don't forget that. If I'm calling the sort method from the class collections, then it's implementing the merge sort. If I'm using it from the arrays class, okay, so it uses here what? The quick sort algorithm, as we mentioned before. The quick sort algorithm, here we go. The sort method of the arrays class uses the quick sort algorithm. Don't confuse that, please. And now we're done. Again, this is a very nice self-check. Okay, what steps would you need to take to sort an array of bank account objects by increasing balance? So now you will compare the balances of the bank accounts. So if you want to sort bank account objects, all you need to do is what? To implement the comparable interface. And in its compare to method, you must compare the bank balances. And we're done with this chapter now. Is it clear, everyone? Is it clear, everyone? Now, any questions regarding this chapter? It was a long chapter, I know, but it's not difficult. Once you understand everything and you know how to implement it, it's not difficult. So again, any questions before I stop my recording? Thank you, everyone. I will just stop my recording now. And then we will continue